Hello and welcome. In this video, we'll be working through some exercises on logarithms. Our main goal is to evaluate logarithmic expressions without the aid of a calculator, relying instead on the fundamental properties of logarithms. By the end of this session, you will be able to apply the product, quotient, and power rules of logarithms to simplify and solve problems. Let's begin with our first problem. The first expression we need to evaluate is log base 2 of 18 minus log base 2 of 9. Notice that both terms have the same base, which is 2. This is a key observation that allows us to use a fundamental property of logarithms. We can apply the quotient rule for logarithms, which states that the difference of two logarithms with the same base is equal to the logarithm of the quotient of their arguments. In other words, when you subtract logarithms, you can combine them into a single logarithm by dividing the numbers inside. Applying this rule to our problem, we get log base 2 of 18 divided by 9. Now we can simplify the expression inside the logarithm. 18 divided by 9 is 2, so our expression simplifies to log base 2 of 2. This is a very special case. We can use another important property of logarithms here. The property states that the logarithm of a number to its own base is always 1. This is because any number raised to the power of 1 is itself. Therefore, log base 2 of 2 is equal to 1. So we have found our final answer. The value of log base 2 of 18 minus log base 2 of 9 is 1. To recap, we use the quotient rule to combine the two logarithms, and then the property that log base a of a equals 1 to find the final value. Now let's move on to our second problem. Log base 2 of 64 plus log base 2 of 2. Again, we see that both terms share the same base, which is 2. This time, we are adding the logarithms. This calls for the product rule for logarithms. The product rule states that the sum of two logarithms with the same base is equal to the logarithm of the product of their arguments. In simpler terms, when you add logarithms, you can combine them into a single logarithm by multiplying the numbers inside. Applying this rule to our problem, we get log base 2 of 64 times 2. Let's perform the multiplication inside the logarithm. 64 times 2 is 128, so our expression becomes log base 2 of 128. Now, we need to figure out what power we need to raise 2 to in order to get 128. This is the definition of a logarithm. We can rewrite 128 as a power of 2. 128 is equal to 2 to the power of 7. So our expression is now log base 2 of 2 to the power of 7. This brings us to our final property for this problem. The power rule for logarithms states that the logarithm of a number raised to a power is equal to the power times the logarithm of the number. A special case of this rule is when the base of the logarithm is the same as the base of the power inside. In that situation, the logarithm simply evaluates to the exponent. So log base 2 of 2 to the power of 7 is simply 7. And there we have it. The value of log base 2 of 64 plus log base 2 of 2 is 7. To summarize, we use the product rule to combine the two logarithms, and then the power rule to simplify the expression to its final value. Let's quickly recap what we've accomplished today. We successfully evaluated two logarithmic expressions without a calculator by applying the fundamental properties of logarithms. First, we used the quotient rule to simplify a difference of logarithms. Second, we used the product rule to simplify a sum of logarithms, and then the power rule to find the final answer. These properties are incredibly powerful tools for working with logarithms. By understanding and applying them, you can simplify complex expressions and solve problems efficiently. Thank you for watching, and keep practicing.